All right, so today I was learning about linked lists and data structure. So basically, here's a little project to go along with that. Um, so I don't really know how to use linked lists. This is my first time trying to implement it myself. I was just reading about them earlier. So we're gonna go ahead and see how this goes. I might not upload this if I'm totally lost and I need to keep doing more research. Then do that. But otherwise, I'll put this video up for you to watch and yeah, I just wanted to record a little thing so you can see because you were saying, I want to see, I want to see. So gives you kind of some instructions on what to do, but it wants you to do what you're doing. So it gives you a little bit of an idea of like what's going on here. And it kind of tells you what to do, but you have to understand like the back end of things. You can't just do what it says; it'll never work. I do like this website. This is fun. It's a good interactive way of learning. Uh, they give you some like theory to read about, and then little practice things like this where you can get a feel for it with some like help. Like there's some assistance here because like if you, I'll show you whenever I like I'll get something wrong on purpose or maybe it'll happen on accident, and you'll see like the corrective action. Um, so we included pass just so we don't have error messages over here. Allows us to go to the next step. Now it's saying to get rid of that because we're going to implement the next thing. So, um, an inner class called node. Let me class. Give me an indentation. Expected an indented block after class on line 2. Linked list. Okay. Inside your linked list class, place the pass keyword in inner class. No, it's not. Same. I don't know actually. I've never seen this yet. I'm going to replace the pass keyword with an inner class called node. Um, um, okay, maybe it is what I think. Maybe we just have to add like some. Maybe we just have to add some more to it. Okay, yeah, that's not okay. So this is exactly what I mean. Like, it doesn't really tell you exactly what you need to do. Now, it said in inner class. This is what I was initially going to do, but I thought I was jumping the gun and adding more than I wanted. And which, if you add, basically, if you skip a step, like say if I did this step 2 and I did what's up and coming step 3, which it won't show me yet what that is. There's no way of seeing the future yet. But if you try and jump the gun, it won't work. You need to do it step by step, and so I didn't want to do too much. Anyway, now we move past from here. You have the node class and initialize method. Oh, wait, that's what I just did. Okay, that was me doing too much. That was me doing too much. I was just giving this the parent class. Was the problem? It wasn't supposed to be. When I said an inner class, I didn't really what I was trying to say. Inner. I thought it meant like I wanted this to be a child class of linked list. Why when you do this, then now this class node, anything an object under this classification, will adopt the inheritance from anything that's in this class. That's what is going on here. So when I said inner, that's what I imagined it was meaning, but anyway, we're going to define a new method init. This is short for initialize. This is how you initialize variables and stuff for your class. So it says here we want 2 parameters. So we got a self parameter and an element parameter. So we're going to self.element. Cannot get it right. Inside the method, assign element to self.element. Yeah, okay, got it. Next. Still inside the initialize button, assign none to self.net. That's the next pointer to where. Later, next to me. Okay. Inside the linked list. Yeah, so I was reading about these linked lists before dinner. I'm not super confident in what I read about them, but I kind of have an idea what this is. Anyway, inside the linked list now. So now it all works off indentation. So you see this line here. Anything here is inside of this class. You have to go outside of this indentation. So back to the outer here, where we're lined up with this one now. So now we're within linked list, but we're not within class node. So kind of like an in between space. So here we're going to define our initialize method for this is our initialize method for linked list, where the other one is for class node. So essentially, what we're doing here is, if we were to do this, this is really what we're doing here. Like, forget this at the bottom. We have this class here. Then within this class, indented, we have this child class, which I guess it's not a child tech. For some reason we're not inheriting. I don't know why we're not doing that. Find out, I guess, pretty. Still in the initialize method of linked list. Set head also to none. Empty at the moment, so none. Okay, add another method. Is empty. Turn of length 0. So this is node count. So for example, if we have node A, B, C, and D, then this would return 4. We'll use this to keep track of how many nodes are in the list, so self.length equals returns true. Meaning that the list has no nodes. Greater than 0 is false. So let's go and see. Let's test your linked list so far. Great, lovely. At the bottom of your code, create an instance of linked list called myList. So we're going to create a variable of myList, and we're going to give it the linked list class to find this object. And using the isEmpty method, I'm going to print. This is where you'll see something on the screen. Prints it to the screen. So over here, we're going to see whatever we type in print call. So in here, we're calling this object. And the method is empty. And it is empty because we haven't added anything to it yet. So it's going to say true. Is it empty? Yes, it is. That's true. So that's what it's printing on here. That's what this none is for. None will return true or false. So if I were to say, for example, print 5, you see 5 shows up. If you wanted to print words, we could do like, I'm gonna not do what I was about to do. Because I guess this is going up on YouTube and anyone can see it. So, yeah. But that's how you put quotes here, and that's how you make a string, what we call it. Now, after this empty method, to create another method called add. And add and it's gonna have another parameter element. Oh, I cannot get that right. Too many E's. Create a variable named node. Assign it to a new instance of node. Oh wait. Okay. Element. If the list is empty, then new node becomes the first element ahead of the list. So inside the add method, create an if statement. Put it. So if we're checking if the list is empty. So if it is empty, then I was just reading the error message over here. I was like, why is there going to be an error? But for some reason, in one, and it's just because the code is unfinished. Okay, so here we have an error. You should assign node to self.head. Okay, so I think it's just because I did backwards. There we go. So I was actually about to do it right the first time. That's like best. If the list is not empty, the method should define the last node and link new node. What's next? So let's see here. It's good saying if there are nodes, I want to find the last one, link it to the next. Just the last. There should do this. Create else block if. So here we give it else. So if the list is empty, then we create this head. If it's not empty, so this is what else is. Otherwise, we want to create a current node. So that makes it. We need to create a loop. Still inside the else, we're gonna do a while loop. So while current node next is not none. So is not looks like this. Here. And inside the loop, we're going to assign current node next to current. Well, current node dot next. None. Not none. I don't know. Uh, inside the else. I don't think we have to delete this line. I think that stays. Then, hello. Maybe not. Um, the all restart. No, I can't delete it all because I have the instructions from last. Uh, um, okay. Then we're gonna go back to the is not. Now, sometimes I don't understand why. I'm still kind of learning, and sometimes these things do confuse me. Like, um, you could say, for example, like this could be is, or this could be is. Like, you could say like 5 + 5 is 10. Uh, or you could say like 4 + 5 is not 10. And so sometimes I get tripped up over stuff like that. Sometimes I have to like go back and reread a lesson or whatever. I also have a book that sometimes I open up and check that out because sometimes I need to troubleshoot stuff via consulting the book. Um, Cause yeah, sometimes the stuff. It's not like I've been doing this for my whole life. Know exactly what's wrong. So a lot of it's still just learning. Um, Anyway, the while loop you just created enables you to go through each node in the list till the last node is reached. Once that happens, you can add the node to the list. Okay, got it. So in our else block still, after the while loop, we want to assign node to current. After adding a new node to the list, you need to update its length at the end of the add method. Going to self length plus equals 1. So I'm going to add 1 to the length. And we do plus equals because it's essentially it's just shortening the thing. Because otherwise we do self.length equals self.length plus 1. And so plus equals just lets you save like rewriting this again the second time. So now let's test adding elements to your linked list. Ooh, this is where it's gonna get fun. At the bottom of your code, after creating an instance of linked list called mylist, printing mylist here, add 1 and 2 to the list using add method. So I'm gonna do my list add 1 2. It's gonna be this. Must add 1. Must add 2. Finally print list. Length is 2. You should print is empty as well. I guess it does say here. I guess here it does say text. I think meaningful, but I guess it wants us just to test that that this function updates and so print that the list is empty. So here we're printing is it empty? Yes, it is. So that's true. Now we add stuff to it, and it's no longer empty. So when we print it again, now it's false because now there are items in it. It's no longer empty. Then we ask what the length is. Length is 2 because we added 1. We added 2. There's 2 items in there. That's what we're getting as our output there. All right, new method going here called remove. You can take self and element and going to create a variable called previous node. But none. Oh, should assign none to the previous node. Or not. Oh, I made a typo. Yes, that's another thing too. If you make any typo, like I can't tell you how many times I've made a typo and it just ruins the whole code. And I look and look and look, maybe sometimes even for like 20 minutes trying to figure out what's wrong, and then I realize there's just a dumb typo somewhere. Like that's what's fucking up the whole code. Alright, so now inside this method, we're going to create another variable called current node. So, oh, and then this starts the traversal of the link from the first node. So that's cool. Now we got some action. Current node will be used to keep track of the current node being examined. Okay. Now we're going to loop through the list. Find the node that contains the specified element move. So we create another while loop. here. Well, current node is not run this. Is not none and okay. I guess actually do is and current node dot element is not. Well, I think when it says equal, I think it's not equal to element. And inside the while loop, we're going to get some current node to previous node. Boom. Next, we're going to assign current node dot next to current node in the while loop. So we just add on to go in here, new line, or was it assign dot next to current node dot equal current next. Takes it to the next one. This moves the current node pointer to the next node in the list during each iteration of the loop. So basically, it just keeps traversing forward, allowing you to traverse the linked list until the element is found or the end of the list is reached. Yeah, so basically, this is just like it's kind of like hopscotch, right? You start on 1, you go to 2, you go to 3, and so this is basically keeping the motion going. We're gonna start at 1, and we're gonna keep going to the next, going to the next, keep on going to the next, without having to tell it every time to go to the next. It's gonna start it automatically now. It's kind of like got some automation going. So now after this loop, indented, right? Create an if statement. Checks if current node is done, then when this happens, the linked list without finding the element move, and the function should stop running. Therefore, add the return keyword. Just return. Huh. If the current node is none, well, okay, I'm missing something. After the while loop, create an if statement that checks if current node is equal to none. Current node, I'll just say is equal to current node is none. Next, create an elif. So elif is an else and an if put together. Right, that's how you get this elif. Else, if. So otherwise, so if this, then return. Otherwise, if previous node is not none, then we want to assign current node dot next to previous node. With that, if the element is if the element to be removed is found not in the head of the node, next pointer of the previous node updated to skip over the current node. Element to be moving it from I mean, sometimes. Why is this? Okay. So yeah, that's what I mean. Like, I don't know this programming language enough that I can just kind of fly through with flying colors. Like, not like I can just ace through anything I want to do. Like, sometimes I still have problems just like that, where I'm still figuring out what exactly the syntax is. Um, so a lot of it is trial and error, but what's more important is understanding what it is that you're doing, uh, and it's less important like execution. Because if you need help, like you could Google like, I'm having this issue with my LF statement. For some reason, I'm getting a syntax error. Why is this happening? Something like that. And it'll probably tell you like, well, usually when there's an LF statement, then it's asking if, and so if this, it's asking for a circumstance, and LF was going to a blank line and then giving 2 lines text afterwards. And so I could probably like read about that, I'm sure, if I was having an issue. Um, so it's more important to understand this stuff, like the aim, what you're trying to accomplish, the problem that you're trying to solve, as opposed to actually solving it. That you can get help with. This you just need to be able to understand it. So that's important. Next we're going to create an else block. So here we go. So, so handles the case where the element is to be removed found in the head node. Updating self.head to point current node. Head node is removed from the linked list. At the end of the remove method. Have it. Alright, wait. Oh, okay. Here we are. At the end of the remove method, decrement self.length 1. So it's going to be self.length minus equals 1. Oops. To take 1 away from feeding head each time as we move on from the head. Imagine A, B, imagine like A, B, C, D, right? And after we move from A to B, then A is no longer worth worrying about. Once we move from B and now we're on C, we don't need to remember B anymore, right? So now C is the new thing. So that's the, right? We're deleting the one that we move on. So now let's test removing an element from the linked list. At the bottom of your code, remove one from the linked list using remove method. So let's do my list remove one. Now we're gonna need to, yeah. Now we're going to print my list length. And so, oh, that was it. I guess we're all done. Whole project. True, false, 2, 1. We'll update here. Right, and all that's saying is that we're creating an object called myList. Right, and we're seeing in the terminal here, we want to see myList is empty. True. Then we add some stuff to it. These are actions that we're taking. So for example, we're using this method add, right? So we're taking action on our list by adding to it twice, and now we're checking it again. Is it empty? Not anymore. And now we add stuff to it. So now it's false. We're updating this object. And now we want to see how long it is, so we're giving it 2. Now we're taking action again, and we're removing 1 from the list. And now it's saying we took 1 away, and now we have 1 left. So, for example, I could, I guess really you could add anything. The number doesn't matter. It has to be something. And I think also here it doesn't matter what I put in there. It looks like if I put a 1, okay, this is not removing anything because it's looking for an 8 to remove from the list. We don't have an 8. So what we do have though is 1, 2, a 3, a 4, 5, and a 6. And we're removing 1. Now, if we were to remove, say, a 5, so we've taken out the 1, and we're taking out the 5, which only leaves us with 2, 3, 4, 6, which is why we're getting 4 here. Anyway, yeah. I just wanted to show a little bit about kind of like how this stuff works a little bit. Because I remember you were asking, like not too long ago, you were like, I want to see, I want to see. So here's a little bit about some of like the exercises that I'd be doing. Like I'll like read about something and then find some sort of like online exercise to try like implementing it. Because it's not like I can just create a project of my own and just every single new thing that I learn keep on adding that on top, because that would be just like a shit masterpiece, right? It'd be like if I was trying to make a um, painting, and every time that I get a new color of paint, I just throw it on there somewhere, right? You can't just aimlessly glue stuff together or mix random colors. I mean, you need to have some sort of scope, some general scope to like what the painting, what you want it to be, and what colors you're going to need, what kind of like um no, that's called color set, like a palette. You need to know like what kind of palette you're looking for. So same kind of like with this. You can't just keep adding stuff on to a project you already have. So that's why I keep trying to find like little exercises of like what I learned today, what I've been trying to get into, like the space I'm trying to move into. Um, so yeah, today I was learning about a new data set called linked lists. So there's singly and doubly linked lists. Single linked list is kind of what this was here. Double linked list can move backwards as well. So like here we're deleting the node after we're done with it because we're on to the next, and it can't go backwards. And the other kind of linked list I was reading about today, you can traverse forwards and backwards. So you wouldn't be deleting these afterwards. You'd still keep them open for afterwards. And so the point of a linked list essentially, these are uh, there's two data structures that I learned about that function off of linked lists, and that's stacks and queues. And I'm sure you know what a queue is. Like when you're waiting in line, you're in queue. Like when we're, one second. Just want to get some water real quick. Um, but you know what queue is. Like when we're waiting in queue for a game on COD, right? I think we're sitting there in queue for maybe a minute, and then we get in a game. And that's a first come first serve scenario. The first person who gets in line is going to be served. The person who gets in line behind them is going to be served after them. The third person gets served last. Once I'm served, I'm taken out of the queue, and the next person behind me becomes the new first person in queue. That's what a queue is. Then you got stack, which is essentially the same thing, but kind of like in a vertical. Uh, and the difference with the stack is that it's a last come first serve basis. So it's stacking, right? So like say we have something on the bottom, and then we put this on top of it, and we put this on top of it. Then we can only take this off the top. We can't take this out of the bottom when there's stuff on top of it. So imagine kind of like if you stack plates on top of each other, plate 1, plate 2, plate 3. You can't take the bottom plate without doing stuff with this top 2. You have to deal with what's on top first to move down. So that's a stack, and then you know what a queue is. And so that's what I was learning about today. And to get into that, I had to learn about these linked lists. So this is a little prerequisite that I was kind of nibbling around with today. So tomorrow, tomorrow I'm gonna be getting into queues and stacks, and then, yeah. So I guess Thursday I'll be working on like binary search tree. That's kind of like if you were to ask me to try and guess a number, right? You pick a number 1 to 100, and I have to guess a number. I would go with 50, right? Because that's how I'm gonna get the most information. I'm gonna say 50, and you're gonna say higher or lower. Say you say higher, then now I'm gonna guess 75, because now that's cutting it in half. Because now if you say higher or lower, I'm splitting the difference as perfectly as possible, so I get the most information. Because if you say higher, I'm not gonna say 51. Obviously, it's gonna be higher. And if on the slim chance that it is 51, then how many more guesses is it gonna take me? If I say 75, you say lower. Then I'll say like 60 or something, you say lower. Then I'll just say like 55, lower, 52, lower. Then I got it. But essentially, that's a binary search tree. But that's much better than if I say, you say guess a number and I say 1, you say higher, and I say 2, you say higher, and I say 3, and your number is like whatever you said, 52 or something, right? Like it's still gonna take 52 guesses to get there as opposed to my like 6 or whatever. So that's what I want to get into tomorrow. Um, well, Thursday. Tomorrow I want to get into the queues and stacks so that I can, from there, get into binary search. And these are algorithms that I'm working into now. Learning algorithmic coding. So from search engines to machine learning and AI and stuff, data processing. Just something that I need to learn, so that's what I'm getting into right now. But yeah, I just wanted to record this little video for you real quick. I saw that there was a little short project or exercise or whatever, so I decided, what the hell, I'll just go ahead and record one. And if it works, it works. But if this was gonna be way too confusing and I was struggling with this and I had no idea what to do and it wasn't making sense, or I had to like consult Google and see like what's going on, like why I can't figure this out, then I was gonna just delete this. But try again. It's like tomorrow or something with like stacks and queues or something. Uh, but I guess that's all. So yeah. Hope you like what you see. All right, and that's gonna be it. Bye bye.